Welcome to sitza.com.
Hess's law of constant heat summation. According to this law, if a reaction takes place in one step, or you carry out the same reaction in a number of steps, the total enthalpy change, the total energy change will be same. So according to Hess's law, if a reaction takes place in several steps, then it's standard energy change, right? Standard reaction enthalpy is the sum of the standard enthalpies of the intermediate reactions into which the overall reaction may be divided at the same temperature. It means if you carry out a reaction, suppose you want to convert the carbon into carbon dioxide, okay? By the combustion of a carbon, you get a carbon dioxide. The energy change here in this reaction, let's write it delta H1. This is the enthalpy change. Now, if you carry out the same reaction in two steps, first if you suppose convert the carbon into carbon monoxide and then the carbon monoxide into carbon dioxide. Here in this, in this part, you can see we are carrying out the reaction in two steps. First we convert the carbon into carbon monoxide and then into carbon dioxide. So when you change the carbon into carbon monoxide, let's suppose delta H2 is the energy change, and here it is delta H3. This is the direct process and this is the indirect process, means you are carrying out the reaction in two steps. So according to Hess's law, the energy change here will be same, whether you carry out it in a same process or in two steps. Means the delta H1 here will be equal to delta H2 plus delta H3. So that means the total amount of heat evolved or absorbed in a reaction is same, whether the reaction takes place in one step or in a number of steps. Correct? This is the Hess's law. Now let's apply the Hess's law on certain reactions. We have a sulfur, it gets converted into sulfur trioxide and the heat changes -395. Sulfur dioxide into sulfur trioxide, the heat changes -98, minus 98 kilojoules. We have to actually find the enthalpy change that occurs when the sulfur goes to the sulfur dioxide. So what is the enthalpy change here? So if I write it the same way, just like we did in the previous example, when you convert the sulfur into sulfur dioxide, sulfur reacts with oxygen and forms sulfur trioxide. Here the heat changes -395, right? So when you convert the sulfur into sulfur trioxide here, okay, this is the direct step process, this is a one-step process. You're converting sulfur into sulfur trioxide and the heat change here is -395 kilojoules. And we have to find if the sulfur changes to the sulfur dioxide, if sulfur is oxidized to the sulfur dioxide. So if you convert the sulfur into sulfur dioxide, what is the enthalpy change? Let's say this is delta H1, okay? And when sulfur dioxide changes to the sulfur trioxide, the heat changes, that means when you change this one into sulfur trioxide, the heat changes -98 kilojoules. So we have to find out the delta H1 here. So according to Hess's law, whether the reaction occurs in one step or in a number of steps, the total enthalpy change will be same, which means that 395 here will be equal to -395, which is a direct process, a one-step process, will be equal to delta H1, right? Delta H1 plus -98 here, okay, this one. So then delta H1 will be equal to -395 plus 98, which is equal to -297. This is the heat change which occurs when sulfur is converted to the sulfur dioxide. Let's take one more example here. we have to calculate the enthalpy change for the reaction when the graphite is converted to the carbon monoxide. So what will be the enthalpy change here? If graphite is converted to carbon dioxide, heat changes this much, and carbon monoxide to carbon dioxide, heat changes this much. So I'm going to write it like this. When you convert the carbon into carbon dioxide, you convert the carbon into carbon dioxide, the heat change is minus 394 kilojoules. And we have to find, when you convert the carbon into carbon monoxide, what will be the energy change. So what is the energy change here, right? Let's suppose this is the Hess, right? Kilojoules, the delta H we have to find. And when you change the carbon monoxide into carbon dioxide, the enthalpy change is minus 283 here. Okay, so according to Hess's law, 3 negative 4 will be equal to delta H1. Let's say this is delta H1 plus negative 283 here. So which means that delta H1 will be equal to minus 394 plus 283 here. Okay, which is equal to minus 111 kilojoules. This is the heat change which occurs when carbon is converted into carbon monoxide. 111 kilojoules of heat is lost. Let's take one more example. Look at the diagram over here and see the different kinds of changes. When P changes to the Q, the heat changes 50 kilojoules, right? And what if the Q goes back to the P? So in that case, what will be the enthalpy change? When Q changes back to the P, it will be again the same, quantity will be same, only thing is now it will be exothermic, right? For the backward reaction, it will be now negative 50 kilojoules, because if the forward reaction is endothermic, the backward will be exothermic, right? This is what you know. So we have to find out which of the following statements is correct. First, P changes to the S. When the P goes to the S, the delta H is minus 10 kilojoules. P to S. This is the starting one and this is the S, right? Okay. When P goes to S, it is, when P goes to Q, it is 50 kilojoules. And when Q goes to S, it is negative 60. So when you want to convert the P to S, so let's suppose this is the direct process here. Okay, let's suppose this is X kilojoules. Okay, so we know according to Hess's law, when P changes to the S, let's suppose this is X, it will be equal to the heat change which occurs when P first goes to the Q and then Q goes to the S, right? This is the one-step process, the direct process, and this is a two-step process, an indirect process, right? And here it is X kilojoules, which will be equal to 50 P to Q, and Q to S, it will be negative 60 kilojoules, right? So it is what? It is then minus 10 kilojoules. So that means the first one is correct. The first option is correct. Now, second one is R to Q. When R changes to Q over here. So when R changes to Q. Now let's suppose this is the Y. Okay. Now this is, a very simple, Now look at this one. If Y kilojoules of heat is changed when R goes to the Q, you can either go from first R to P and then P to Q, or you can go from this route, right? You can go either from this route or you can go from this route. You can make the calculation from this side or from this side. Both ways it's correct. Now let's go from first R to S. If the heat changes 30 kilojoules, and when S converts to the Q, from Q to S it is negative 60, from S to Q it will be plus 60, right? Okay. Now according to Hess's law, Y will be equal to, Y is equal to 30 here, plus it is now S to Q is 60, so which is 90 kilojoules. Okay, so that means the second one is also correct. Coming to third one, P to R. P to R. So we have to find this one. And what is this one? Okay. Now as we have calculated these two, you can you can calculate this P2R either from this triangle here, or you can get it from this triangle here. Means if you want to calculate the P2R change, you can first find the P2S change and then R2S change, right, from this triangle. Very simple, right? Okay, so let's suppose here I'm going to calculate it from here. When P to S, when P changes to S, the heat changes. When P changes to S, the heat changes negative 10. The X actually we calculated is minus 10 kilojoules, right? Minus 10 kilojoules. And when R converts to the S, it is 30 kilojoules. So according to the Hess's law, X here in this case is what? X here in this case is negative 10. So I'm going to write it down minus 10. It will be equal to P to R, right? Plus 30 kilojoules. Okay, so when P converts to the R, PR will be equal to, this amount here. Okay, this amount will be equal to minus 10 minus 30, which is actually negative 40 kilojoules. Okay, this is negative 40 kilojoules. So when P converts to the R, it will be minus 40 kilojoules. Heat loss is 40 kilojoules. So that means the option third is not correct. So only the first and the second option is right. The first and second is right. The third one is wrong. Hope you got the concept. Thanks for watching the video. Bye for now.